Welcome to our next lesson on structured data in Java, which will deepen your knowledge of Java array traversal via a new control flow construct, the Foreach loop. After completing this lesson, you will understand how the Foreach loop can greatly ease access to and processing of arrays. You will also be familiar with the key differences between a normal for loop and a Foreach loop. Finally, you will recognize the limitations of Foreach loops and know the cases where a normal for loop must be used instead. In this lesson, we will explore an additional way that Java provides for easily processing arrays, and which is also applicable to other Java structures that will hold data for us. So far, when we want to process all the elements of an array, we have written a for loop that iterated over all possible index values from 0 up to the length of the array, and then used that index to access each element of the array. This is known as an array traversal. You can think of it as walking across the array and processing each element encountered along the way. This is common when we want to print the elements of the array or search the array for a particular item or similar array processing issues. This is such a common task that Java added an additional loop construct just to handle it. It is called the Foreach loop. It starts with the keyword for, similar to a normal for loop, but what goes inside the parentheses is quite different. Instead of declaring and initializing a loop counter variable, you declare a variable that is the same type as the base type of the array. That is followed by a colon, which is then followed by the array name. Then in the loop body, you can use the loop variable you created rather than using an indexed array element. The loop variable will be assigned the next element of the array on each iteration of the loop. Thus, the Foreach loop is equivalent to this standard for loop where we declare a loop counter variable and have it iterate over all possible index values, and then assign the next array element to a local variable which we then use in our calculations. Consider this example where we want to compute the average of all the values contained in an integer array. We saw this example several times already. We declare and initialize our cumulative sum variable before the loop. Then we have a Foreach loop that gets each value from the array and adds it to the accumulator. Notice how the Foreach loop greatly simplifies the processing by getting rid of the integer loop counter and subscripted array expressions. When looking at this code that contains a Foreach loop, you read it as, for each integer num in the array numbers, do the following, where in this case we add that num into the total. Here's another example. In this case, we have an array of integers and we want to report the largest value in the array. We call the method max to find the maximum value for us, which we then print out. And here is the method named max that receives an integer array as a parameter. We initialize the variable max so far with the first element of the array, and then we use a Foreach loop that says, for each integer num in the array numbers, if num is larger than max so far, then assign num to max so far. When we exit this loop, the variable max so far will hold the largest value in the array, and we return that value. Note that the values in the points array represents the points scored by the Golden State Warriors NBA team over their past 5 games at the time this lecture was recorded. When we compare for loops to Foreach loops, we find that the standard for loop is always safe and you are free to use it whenever you wish. However, the Foreach loop can make your code much easier to read by other programmers, and so you are encouraged to use it as much as possible. In addition, the Foreach loop is applicable to other collections in Java where the standard for loop cannot be used. We will investigate these collections in our next few lessons. And because of this, the Foreach loop is preferred over the standard for loop in most cases. Unfortunately, the Foreach loop does have some limitations. The Foreach loop is only good when you want to read the data in the array, and thus it cannot be used if you want to change the data in the array. That is because if you assign a new value to the Foreach variable, you are only changing the Foreach variable, and you are not changing the corresponding element in the array. Additionally, since there is no loop counter variable, you do not know which element of the array you are processing on any given iteration. Thus, if you wanted to return the index of an array element that you are currently processing, you cannot do that. Another limitation of Foreach loops is that they always process the array in a forward direction and always in single steps. Thus, if you want to process an array in reverse order or in steps other than 1, you cannot use the for each loop. And additionally, a for each loop only iterates over a single array, and thus it is not the best choice when you have a loop that needs to process 2 or more arrays at the same time. But these restrictions are minimal, since most of the time we are simply traversing a single array, in which case you are highly encouraged to use the for each loop. And even if you do not use the for each loop yourself, you need to be able to recognize and understand it when you see it in code written by others. This lesson deepened your understanding of array processing and traversal in Java. Now that you have completed this lesson, you should be familiar with the concept of array traversal and understand how the Java for each loop can greatly ease access to and processing of arrays. In addition, you should be familiar with the key differences between a normal for loop and a for each loop. Finally, you should recognize the limitations of for each loops and the cases where a normal for loop must be used instead.